This video is on centered component scores. The reason why this topic comes up is because when doing a principal component analysis in SAS, the default is actually to calculate centered component scores as opposed to uncentered component scores. Component scores are just centered component scores are component scores as deviations from their respective means. So if we go back to video 4.13, we had this equation y equals xk, where we took the original data matrix that we had, this one right here, and we post-multiplied this by the matrix K, which is the normalized eigenvectors, and we got these component scores. Well, these component scores are uncentered component scores. Both kinds are useful, but they're useful for different purposes. Now, to get to centered component scores, it's the same thing except that this data matrix A is going to be centered. And as I alluded to before, we're just going to find deviations from their respective means. So what we're going to do here is calculate the means, calculate the average of this one, and we're going to bring that across. Okay, let me shade it a little bit differently, or maybe this. Okay, so those are the means, and we want to put that up here. So what I'm going to do is just highlight these and say this is equal to these minus the means, and I'll hold those numbers constant throughout. Okay, so we take the centered data matrix x sub c, and we're going to multiply it by our matrix of eigenvectors. It's giving me trouble. There we go. Control Shift Enter. And this is what we got. If you looked at the video on where we did principal components using SAS, this is output that we got. But either way, if you were to directly calculate the variance of component scores in either the centered or uncentered Y matrix, here's the centered and here's the uncentered, you'll get the same value, and I'll demonstrate that here. So if we took the variance, goes variance of this first one, and this is the variance of the second one, we get 37.345 and 5.020, which is what we had previously calculated. But if we do that for the same thing here, we get the same values, which is pretty interesting. So we can see here that the eigenvalues are in fact the variances of the component scores, whether it's uncentered or centered.